So this is going to be our PCB schematic design layout video. This is a broad view of our PCB design. Let me just save it here. So right here in the bottom we have the AVR, and just to start off with describing all the connections. So we're going to have lots of sockets that we are going to use as the connections into the AVR so that we can easily move the devices around. So just to go over the list from port A and port B, port A0 is going to be for the ultrasonic sensor, same with 1. Port A2 is going to be the output for the buzzer. Port A3, 4, 5, and 6 are going to be in 1, in 2, in 3, and in 4 for the motor driver. And A7 is going to be the input into the motor driver for the enable for the turning motor. For port D, we're going to have the two connections to the RC. One for the front back direction and one for the turning direction. We're going to have port D3 be the metal detector input, and ports 4 and 5, or pins 4 and 5 for the screen. We also will have ports 6 and 7 in D as extra as necessary. We also have the reset switch connected here via a capacitor, just like how we have for the other AVR breadboard. The input here also is connected via a capacitor to regulate the voltage input. And yeah, we have ground connected here as well. Moving on to the motor driver, we have ports in 1 into both connected to the AVR itself, and in 3, in 4, and enable B, all connected to the AVR. But enable A is actually connected going to be straight from the remote control, and that's just going to be controlling how fast it's going to be. We just chose this since we thought it'd be easier to use it just straight from the remote control, because it'll just be a fast PWM signal, and that doesn't have to have a high voltage. It can be within the 5 volts that the remote control operates off of. We also have the VDD. This is going to be the voltage for the logic inside the motor driver, and a 9 volts connected to the VS that's going to power the outputs here. We have two sockets here also for measuring the current, making sure it's not getting too hot inside the motor driver, and a connection to ground. Next, this is one of our other circuits. This is mostly for regulating the voltage, so we have a clamping circuit and a capacitor across here, just to make sure that the voltage doesn't go too high and that kind of thing. The motor driver is suspected to drop the input into it VS by about 2 volts, but this will also just make sure that it won't get too high anyways. We decided to use Schottky diodes too, because they are better for fast changing, which is what the PWM is pretty much working for. And as you can see over here, these are also going to be sockets that we're just going to be soldering into to connect to the motors themselves. So J3 and J4 are for the front back motor, and J5 and J6 are going to be for the turning motor. So pretty much we're going to have one motor to make the wheels spin forward versus backwards, and that's going to be based on the out 1 and out 2. And we're going to have one motor to turn the wheels to go left or right, and that's going to be for out 3 and out 4. Another thing I just wanted to point out is that the capacitors that we use in our PCB are all going to be the same. They're all going to have a relatively higher capacitance, as that's normally better for stabilizing the voltage across specific parts. So we're going to be using about 100 microfarads for our capacitors. Moving on to the 5-volt power source regulator, we're going to use the LM7805 to regulate the voltage input to the 5 volts. So all the other places where we see the VDD, That's going to be like the AVR voltage input and the logic input for the motor driver. It's all going to come from this. So we just put in a higher voltage, higher voltage into the socket input here, J2. It'll go through here, and then it'll output a constant 5 volts with VDD. And just to stabilize that even more, we're also going to be using a 100 microfarads capacitor right there as well. So finally, moving on to our PCB schematic. It has pretty much the same layout in terms of like where everything kind of is, but just to go over it a little bit, we've got the AVR right here and some of the inputs right along here. The reset switch will be right here. Motor driver right here. The J8 is going to be the RC input. J12 is going to be the input for 9 volts for the motors themselves. Got some capacitors here, and then this is going to be the 5-volt regulator right here. All our diodes are just around here, and then these are going to be our inputs for the motors. We got the 4 mounting holes just to stabilize everything, and we also, as you can see, we also used the filled in zones to make their 5-volt layer, which is going to be red, and then we also got a ground layer, which is the blue layer right there. And yeah. The reason we had used a layer for 5 volts and for ground is just to reduce the risk of heat and the dispersion of heat, sorry. Yeah, so there with there being a layer, it's better for the dispersion of heat. And just to show you in the 3D viewer, this is what our circuit will look like. Yeah, looks pretty nice.